Hello, and welcome to Exploring the Atom. I'm your host, Bill Nye.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Today we'll be taking an adventure through time and space. Let's start at 400 BC, all the way over there. There was once a guy named Democritus.
Dude, sir!
He had an idea that these things called atoms make up everything in the known universe. But later on, another guy named Aristotle came in with his own theory. He thought that the only matters in the known universe were earth, wind, fire, and water. We now know today that this is false, and he was kind of stupid. I wouldn't take him too seriously either. After all, he thought mucus was your brain melting through your nose. It wouldn't be years later until the next chemist jumped in, Antoine Lavoisier. In the 1700s, he opposed the ideas that were currently presented by mainstream science. He tried to disprove the idea of phlogiston, and he did. He disproved that theory, and afterwards founded oxygen and hydrogen. Later on, about 100 years, John Dalton would go on to build off of Democritus and the theory of the atom. So this guy named John Dalton, right? He came up with an idea for an atom called the solid sphere model. It was originally presented as the smallest thing in the universe, but that was false because there were particles smaller than that of the atom. But there was one fatal flaw with Dalton's model. It presented the atom as the absolute smallest thing in the universe. It wouldn't be until the late 1890s that a scientist by the name of Joseph John Thomson would conduct experiments to prove the existence of even smaller particles called electrons. As you can see in the plum pudding model.
Plum pudding.
It's a cloud of positively charged energy, and the electrons are floating in this cloud. And that's what they originally thought an atom was made up of. Just a circle of positive energy with some electrons in it. John Joseph Thomson proved the idea of the electron through cathode ray experiments at Cambridge University. By using the charge to mass ratio and magnetic and electric fields, he proved Dalton wrong, that there were particles smaller than the atoms, which were electrons. He received a Nobel Prize for this in 1906. Later on, though, a guy by the name of Robert Millikan decided to determine the charge of an electron. Robert Millikan used the oil drop experiment to find the weight of an electron. He found the smallest common denominator, which was 1.602 times 10 to the 19th. He denoted it to 1 negative. His findings was within 1% of the accepted value. A discovery made 100 years ago with minimalistic equipment was within 1% of the correct answer. Then he used that value to calculate the mass of an electron. The mass of an electron was 9.1 times 10 to the negative 28th grams, or 1,840th the mass of a hydrogen atom. So then, later on, this guy named Rutherford came in. And he had an idea about the atom. He thought that inside the atom, it wasn't just a big old circle with floating particles, but that there was a central point called the nucleus. And he tested this theory. So he took positively charged alpha particles versus solid matter and combined them in his experiment, the Rutherford experiment.
In Rutherford's gold foil experiment, he shot positively charged alpha particles at gold foil, and because it hit the center and bounced off in different directions, that proved his theory that there was a nucleus in the center. Otherwise, it would have just gone straight through.
Because Rutherford proved the existence of the nucleus, he designed a new model based on this. This is the Rutherford's model. It has a positively charged nucleus, because taking off of the theory of the positively charged cloud, then it also has electrons with a negative charge floating around the nucleus. This happened when Ernest Rutherford was alive in the early 1900s. Joseph John Thomson used the experiment with the cathode ray tube. This was using magnetic fields on cathode rays to prove the existence of electrons. He received a Nobel Prize for this in 1906. Robert Millikan used his oil drop experiment. What he did was he sprayed some oil in this little container right here, up in here. In this tube right here, where the several thousand volts were being pumped in, there was a uniform electric field that was bearing down like this because of the positive charge up here and the negative charge down here. So it was going this way. Well, the oil spray, when it went down, went like that, and he used a microscope to see the charge of an electron. He used this charge to find the mass of the electron, which was 9.1 times 10 to the negative 28th, or 1,840th of the weight of the mass of a hydrogen atom. Science rules. Around the same time the Rutherford model was created, this guy named Bohr came in and created a planetary model. This essentially was the same thing, except it had different ways the electron revolved around the nucleus. So you had the nucleus in the center with the positive charge, but instead of this, where it would go around like that, it actually that, in giant circles, in uniform fashion around the atom. And then you can see the electrons floating around it with the negative charge. This was called the planetary solar system model because, like the planets in a solar system, it was revolving around the nucleus or the sun. So after all the models of the atoms were created, this guy named Schrödinger came in and created his own model. It was an amalgamation of all the previous models used to make a new, updated, and better one. So at the nucleus, there were neutrons, which are the black ones right there, which were founded by James Chadwick. There are protons, which were found by Ernest Rutherford, and they both combine to create the center of the nucleus. Now, neutrons don't have any charge at all, whereas protons have positive charge. And on the outside, electrons have a negative charge. You can see them revolving around the atom. Electrons were found by Joseph John Thomson, and they were all created, then put into one central model, which is known as the quantum mechanical model. So in order, it went Dalton's solid sphere model, the plum pudding model, Bohr's planetary solar system model, Rutherford's nuclear model, and then finally Schrödinger's quantum mechanical model, which is what we still use today.
Es ist dem Feind gelungen, die Front in breiter Formation zu durchbrechen. Im Süden hat der Gegner Zossen genommen und stößt auf Stahnsdorf vor. Der Feind operiert jetzt am nördlichen Stadtrand zwischen Frohnau und Pankow und im Osten ist der Feind bis zur Linie Lichtenberg-Marsdorf-Karlshorst gelangt.
Mit dem Angriff Steiners wird das alles in Ordnung kommen.
Mein Führer, Steiner
Konnte nicht genügend Kräfte für einen Angriff massieren. Der Angriff Steiner ist nicht erfolgt.
Es bleiben im Raum Keitel, Jodl, Krebs und Burgdorf.